Okay guys, so let's get right into this problem. This is FRQ number 3 on the AP pre-calc exam. So make sure you understand how sinusoidal functions work and how all this works before coming into this video and trying to try this out. So yeah, just make sure you know that, okay? So let's get right into it. So it says the figure shows a pencil sharpener on a level surface. Point B is located at the end of a handle that is 2 inches away from the center of rotation. The handle rotates in a clockwise direction, and completes 2 rotations every second. At time t equals 0 seconds, point B is located directly below the center of rotation. The center of rotation is 3 inches above the level surface on which the pencil sharpener sits. As the handle rotates, the distance between point B and the level surface periodically increases and decreases. Okay, so what does all this mean? Okay, so when you guys see this FRQ on your test, I really want you guys to to really just break this FRQ down first before delving into into these other problems here, right? So really just understand this, okay? So really just try to break this problem down and understand what it's asking you and how the problem works, okay? So we have a pencil sharpener here, okay? And it's sitting, it's sitting in a level surface right here. So this is, let's just pretend this is the level surface. I know this isn't a great, drawing, but that's the level surface right there. This is 0 inches right there, right? That's 0 inches. This is, okay, so we're focusing on this handle right here. We're focusing on how this handle creates a height, okay? So if it, if it moves here, so if the handle moves here, it's going to be a different height, right? Because it's here, right here is, well, it says it's at 1 inch, but, we'll get to that later. But right here, it's going to be at a different height when it, as it moves like this, because it's moving clockwise, it's moving like this handle is going to go like that, right? And then as it moves here, it's going to go like this. So it's going to be at the same height that it was here. And then now it's going to go like this. So how it's, how it is on the drawing, right? So just make sure you understand that, okay? Make sure how these, just make sure you get familiar with how these problems work, okay? So, just really just make sure you understand that. Let me actually make this a medium eraser, not that big. Okay, so, it's telling us that, the period of this, these rotations is P equals 2 rotations every second. So try to understand, guys, that period, try to just, well, not really memorize, but just understand. Math is not about memorizing things. Math is, about really just understanding and grasping concepts, okay? So period is time over cycles, okay? So, this is something you learn in physics if you did waves, sound waves, light, or something like that. But, you can also be taught this in pre-calculus. This is the same thing that you learn in physics, okay? So time over cycles, okay? So it's telling us that it does 1 second, so every second, right? That's going to be 1 second right here. So that's going to be our time, and then our cycles, it says it does 2 rotations. Rotations is the same as cycles, so we have 2 cycles. So that means that our period is going to be P equals 1/2, which makes total sense. If it's completing 2 rotations every second, how much is it taking for it to complete 1 rotation? 1/2 of a second. So that's really all that it means, okay? So the period just means how much it takes to complete 1 cycle, okay? So we're learning that it takes 1/2 of a second to complete 1 cycle because it takes 1 second to complete 2 cycles. So if you just break it in half, you have 1/2, which is 1 cycle, right? So let's get right into the height of how this problem works, okay? So the radius basically of this circle, because this is going to form a circle here. The radius of the circle is going to be 2 inches, okay? So just understand that it's going to be 2 inches, okay? But it's saying that the center of rotation, this is the center of rotation right there, is 3 inches. So this is 3 inches above the level surface. So if you do 3 minus 2, that means that when it is at the minimum point, when it is right here at point B, that means that the height of the handle is at 1 inch. Okay, so it makes sense when it moves like that. So when the handle is like this horizontally, it's going to be at 3 inches because 1 plus 2, since the radius of the handle is 2, 1 plus 2 is 3, so it's at 3 now, right? So now once it moves up, so let's say this is the maximum point right here. This is our maximum point. It's going to be 5 inches because 3 plus 2 and 3 minus 2, right? So 3 plus 2 is 5, right? So our radius is 2, right? So you're really just finding the maximum, the minimum, and the midline. Okay, so this is going to be our maximum. Once you understand the maximum and the minimum, that's all you really need to do in this problem. Okay, just find the maximum and the minimum. And I guess you can find the midline from here too. So this would be the midline here. Okay. All right. So that's all we need to, to understand for this problem in the pencil sharpener here. Okay. So now let's go down here. So on the AP exam, you're always going to see these points right here. So you're always going to see 5 points, which is going to be F, G, J, K, and P. And you're always going to solve for these 5 points here. Okay. Of course, you're going to be different. Like, this whole thing is going to be different on the AP exam. You're not going to have the same, you're probably not going to have a pencil sharpener. You might have a wheel, or a ride or something like that, but it's not going to be the same example, but it's going to be in the same structure, you know what I mean? So yeah. Okay, so we have to find F, G, J, K, and P. So I know it says no scale is indicated and no axes are presented in the problem, but really just understand, just try to draw the y-axis here, just to try to understand how the problem works. So we already know that the height is going to represent our the height is going to represent our h of t, so it's it's going to represent our y values. Okay, so this is the time, h of t is just the height. This is just the height over time. It's it's literally what we're trying to find, the height over time in seconds, right there. Okay, so at f is our maximum point. So if f is our maximum point, that means it's going to be at 5. So we already found the y value for f, which is 5. Our p is going to be at the maximum too, so it's going to be 5. Our j is going to be at the minimum, and what's in between 5 and 1? You literally, if you want to do this algebraically, I guess you can just add this and divide it by 2. So it's going to be 6 divided by 2 is 3. And guess what? That's our midline right there. Okay, which is what we found over here, right? Okay, so just understand that. Okay, so our midline is just half, or what's in between 5 and 1. And what's in between 5 and 1? 3, because 3 plus 2 is 5, 3 minus 2 is 1, so it's 3. Okay, so our midline is going to be 3. All right, so that's going to be our midline right here. That's going to be our y value. And then this right here is going to be our 1. That's going to be our minimum. It's not, okay, actually, let me redraw this. This is going to be our minimum right here, since j is right there, so it's going to be our minimum. But remember, the 1 is, of course, above the x-axis, so just keep that in mind. Okay. Right, and then you can just draw this thing right here, just so you can visualize it better. And yeah, so this is going to be our 1 right there. It's, so here it started, it's saying that point B is at t equals 0 seconds. Point B at t equals 0 seconds is at the minimum, right? So that means that it's going to start from 1. Okay, so that's 0 right there. That's that's point, that's 0 seconds right there. Okay, so then now it goes up, right? And okay, so this is when we have to understand how the period works. Okay, so if it starts from here at B, right? B equals time, B, so the minimum at time equals 0 seconds. It's going to go up, so it's going to go like this, boom, up to 5, to the maximum, and then it's going to go down again. Okay, so if it's going to go up and then it's going to go down, it completes 1 full rotation, and we said that 1 full rotation is going to be 1.5 seconds. Okay, so let's make little points right here. Let me just that's J. Oh, sorry. Okay, and then our P. Okay, so J represents 1 full rotation. Okay, and this is what I want you guys to do. I want you guys to draw, draw this, especially if you have problems like this where the F is not the starting point. Okay, the F is not the starting point in this problem, so you have to kind of draw the line and kind of visualize it better. Now, don't confuse the points. Okay, don't you always try to have the same points. Okay, so we know that this is a maximum, so we're gonna put 5 there. Okay, so J is 1/2 because 1 rotation. Woo, that's 1 rotation right there. It's 1/2 seconds. Okay, so that means that this right here is what? It's 1 second, right? That's 1 second right there. Okay, and that's also going to be at 1 because it's the minimum. Okay, so now we just have to find. So F we can see it's it's in between 0 and 1/2. So we just have to find what's half of 1/2. So what is half of 1/2? Well, 1/2 is 0.5, and what's half of 0.5? Well, it's 0.25. And how do we model this 0.25 or a quarter as a fraction? That's going to be 1/4. Okay, so that means that F is going to be 1/4 because it's half of 1/2. Okay, so now how do we have, how do we get G, okay? So, okay, so this is where you have to be able to understand how to work with fractions, okay? So what's half of 1/4? Half of 1/4, if you remember 25, you divide it by 2, it's going to be 12.5, okay? So that means that 0.25, half of 0.25 is going to be 0.125, okay? And how do we represent this as a fraction? 1/8, okay? 1/8 is 0.125. You can put this in your calculator and test it out. Of course, you're not going to have a calculator on the test. That's why you need to be able to work with fractions and know what fractions represents. At this point, you should be very good with fractions if you're in pre-calc. So yeah, okay. So if 1/8 is 0.125, then that means that this point right here is going to be 1/8. Of course, comma 3, because that's at the midline. Okay, so it's going to be 1/8 right there because it's half of 1/4. Okay, it's at it's at the middle, right? It's between 0 and 1/4. What's half of 1/4? 0.125 or 1/8. Okay, so it's going to be 1/8. And then if you just keep increasing by 8s, this right here is going to be 2/8. But 2/8, if you divide this by 2, you're going to get 1/4, and that's why this is 1/4. Please on the AP exam, do not write this like it's 2/8 because you're going to get it wrong because you didn't simplify the fraction. You have to be able to simplify fractions. We are on pre-calc, and the AP College Board, they're not going to take that. Okay, so make sure you simplify your fractions. But I'm just trying to make you guys understand how these fractions work. Okay, so we have 1/8, then you have 2/8, but it's actually 1/4, and then right here you have 3/8 because 1/8, 2/8, 3/8, 4/8, 5/8, 6/8. Okay, but we'll get to that. Okay, so this is going to be 3/8 right here. Okay, so then we have 4/8. And 4/8, remember, 4 out of 8, that's just 1/2. Okay, so that's why we write 1/2 there. Okay, just really understand that. Okay, so then let's look at our point K, and so since this is 4/8, we're gonna keep counting by 8, so this is gonna be 5/8. You cannot simplify further 5/8, so you're just gonna leave it like that. You could do this. Okay, I'm deciding to do this in fractions, but you could do this in decimals if you like. You could put right here 0.5, you could put right here 0.25, you could put right here 0.375, which is what it is, and then you could put right here 0.125. I just like working with fractions better. I don't know about you guys. You could do this in decimals, okay? But I'm gonna do it in fractions, okay? And then right here in point P, if we keep counting by 8s, you're gonna have 6/8, but we can't write it as 6/8, so we're going to simplify, and that's gonna be, if you divide it by 2, you're gonna get 3 and 4. So this right here is gonna be 3/4, which I mean, it totally makes sense. Between 0.5 and 1, what do you have? 0.75, right? And that's 25 right there, and 25. So that's the middle, right? So it's going to be 3/4 because that's how you represent 0.75 as a fraction. Okay, and right there we just found our coordinate points. We literally have just found our coordinate points. So this is going to be 1/4, 5. This is going to be 3/8, 3. This is going to be 1/2, 1. This is going to be 5/8, 1, and this is going to be 3/4, 5. Okay, guys, so that's how we find the coordinates, okay? But we still have more work to do, guys. This is a really long FRQ, okay? This is probably the longest FRQ on the AP exam, I think. I'm not sure, but it's probably one of the hardest ones. That's why they're giving it to you, okay? So you can practice these kinds of problems, right? So now, I hope you guys have learned about sinusoidal functions. This is how you write a sinusoidal function as a sine form. Okay, so you see as sine, it's not cosine, it's sine. Okay, so we have h of t, can be modeled as h of t, a times sine b t plus c plus d, right? So that's how you write a sinusoidal function in sine form, and in cosine, but the difference is that this one has a sine. Okay, so find the values of the constants a, b, c, and d. So we're finding a, b, c, and d. Okay, so what is a? Remember, a is the amplitude. A is just the amplitude, okay? And remember, the amplitude is just the radius. So what was here? It was increasing by 2, and it was decreasing by 2. So the amplitude is 2. So our amplitude is going to be 2. You can also look at the graph, and you can see that it's going to be from 5 to 3 you get 2, and from 3 to 1 you get 2. So that's going to be our amplitude, okay? So okay, so from here, our amplitude is actually going to be a positive amplitude because it is starting from the top right here. And when it starts from the top, then that means that you are going to have a like the amplitude is going to be positive. If it were to start from the bottom, so if it's if it's going to start from here, it's going to be a negative amplitude. Okay, so here we're starting from the top because it's F right here, and yeah, okay. Or you could say we started from 1/8, and remember a sine graph kind of looks like this, and when a sine when a sine graph looks like that, then that means that the amplitude is going to be positive. But if the sine graph looks like that, so if the sine graph looks like that, so if it's going like this, if it's concave down, or if it's concave up, and it's it's going down like that, then the amplitude is going to be negative. It's going to be a negative amplitude. If it's like that, if it's going up, then it's going to be a positive amplitude. Okay, that's for sine graphs. Okay, so I really hope you guys already know this, because you should know this already. When you're hopping into the FRQ. So yeah, okay. So our B, what is our B value? So remember, B is just with cosine and sine functions. Our B is going to be 2 pi over the period. The period of our thing is 1/2. And that's just going to give us, you could do the whole thing here, 2 over 1, that's 4 pi. Okay, so we're going to get 4 pi for the B value. And we're going to do our C. We're actually going to leave our C for last because that's the hardest one to find. And our D is just our midline, which is 3. And it's a positive 3, it's not a negative, so we're going to have 3 right there. Okay, so our C. So our C just indicates that it's our phase shift. So let's just figure out if this function has a phase shift. Okay, so it's asking us to find the sine version of this function. Okay, so remember, sine just means this. Okay, so where on the graph do you see this? Well, we see it right here. We see it right here. Of course, you could say that you see it here, but we're not going to do that one because that one's the last. But this one is the first one you can see, and it goes like that. Kind of goes like that, right? So what does that mean? Okay, so as you can see, it didn't start from the it didn't start from the from the midline. So if you have a if you have a sine function that starts directly like that from the y-axis, so you have it like that, that's a function without a phase shift. Okay, and the phase shift is the C value. Okay, so if you have a function that starts with their sine graph kind of like this, so it's not starting from the from the y-axis, then whatever their x value is going to be their phase shift. So right here we see that it's not starting, that the sine function is not starting from the y-axis. It's starting 1/8 seconds later. So that means that our phase shift is actually going to be 1/8. Okay, if you were to write this, if you were to write this equation out, you would represent this with a negative. Okay, so I would recommend you to leave this negative just so they know that that you understand that the phase shift is going to be written as a negative on the function. So yeah, the C, which is the phase shift, it's just how the sine function is shifted. So the sine function starts here. It's not starting at the midline. If it were to start here at 3, at 0,3, then that would have been no phase shift. So we wouldn't have a C value. The C value would be 0. But since the sine function from here like that is starting at 1/8, then that means that it was shifted to the right 1/8 units. And remember, this the phase shift is just a horizontal. It's just a horizontal translation. Okay, so the phase shift is just a horizontal translation. So horizontal translations, remember, they're always the opposites. If you're moving to the right, you're subtracting, and if you're moving to the left, you're adding. Okay, so when you were to write this function out, you would actually do a minus 1/8, but that just means that it's going to the right 1/8 units. Okay, so now let's do C. We just got rid of the hard parts, which was finding the coordinates and writing this, or and finding the values of these equations. But now it's C. Okay, so C is telling us that we have to refer to the graph of H in part A, the T coordinate J. So we're gonna look at J. So where's J? J's right here. Okay, J is the minimum. Okay, so and then the T coordinate K, which is which is T2. So K, so from J to K, on the interval T1 to T2, from J to K, right there, these. Which of the following is true about H? So H is positive and increasing, H is positive and decreasing, H is negative and increasing, H is negative and decreasing. Okay, so something I need you guys to understand is that when it's asking you for if H is positive, if H is positive or negative, what they're trying to tell you, what you need to know to to get this right is that, okay, if the functions, this is negative y, right? This is positive y. If the function is over here, right? Like let's say the function's over here, right? Then that means that if they're asking you for some intervals, say they're asking for this interval, and so this interval, that means that the function is going to be negative. So if the y values, if the y values of the function are below the x-axis, then that means the function is going to be negative. But if the, if they're asking for, for an interval that is, here, from here to here, on which the y values are positive, then that means that the function is going to be positive. Do not confuse this with rate of change. Do not confuse this with concavity. This is just asking for the y values of the function. When you're seeing if it's positive or negative, it just means where are the y values of this function at. And right here, let me just get rid of this drawing right here, so it's better. Okay, I'm sorry. So right here on this, on this one graph that we just made, we can see that none of the y values are negative. They're all positive because, of course, as you can go back and check on this pencil sharpener, you cannot have a negative height, right? We're talking about positive heights. You can never, it's not going to go under the surface. That's just not how pencil sharpeners work, right? So you're always going to have positive. So usually, I'm not saying always, there could be a problem they throw at you where it is negative, but usually on these, the H is always going to be positive because usually real world examples never have kind of like a negative height. And usually these are testing you on the height, or, of something, okay? So you can automatically eliminate C and D since they're negative, but just remind yourself that they're asking you for the y values. They're asking if the y values are negative or positive. In this case, they're positive, okay? So it's between A and B. So from J to K, is it increasing or decreasing? Well, it's increasing. It's going like this. So it's increasing, so it's A. Okay, so now let's see number 2 right here, C2. Describe how the rate of change of H is changing over the interval T1 to T2. So the same thing. How is the rate of change changing from J to K? So we can just say that the rate of change, the rock, whatever, is increasing. That's literally all you have to put. You could put that it's increasing at an increasing rate, but you don't really have to put nothing else. You can just say that it's increasing. That's what I would put. I wouldn't write too much just so I don't get it wrong and you know what I mean. But yeah, you could just say the rate of change is increasing at an increasing rate. I actually forgot the rate. Okay, guys. So this is it right here. This is the final FRQ. So these are all the solutions for the FRQ. I know this was a long video, but you guys, I just had to break this FRQ down into really small steps so all you guys could really understand this and how these FRQs work. But yeah, I really hope you guys enjoyed this video. I really hope you guys can do well on this, AP pre-calc exam that we have coming up, and really just do well. Try to master these FRQs, and I really hope you guys, like the video, subscribe, leave a comment on what you're confused about, or if you need help. And yeah, guys, thank you. Thanks for watching, guys.